Okay, so this video is all about equations, straight line graphs, and in particular y equals mx plus c. However, before we go on to y equals mx plus c, I just want to kind of recap what you remember about straight line graphs. So I want you to pause the video, and then I want you to have a look if you can match up the equation of each one of these 12 with the equation down the side. So I'll give you a couple of minutes to have a go at doing that. So pause the video, and then when you think you know what the answer is, play it again and I will run through the answers. Okay, so I'm just going to make some notes because we might actually need these if we are asked to do a reflection question. So if I have a horizontal line, so a horizontal line, so we have something along this line, this one here, then we know it is y equals something. We know that because we know it crosses the y-axis at some point. So the first ones we're going to look at is the ones which are horizontal lines. This one here would cross the y-axis at 6, so I know that this equation here would be y equals 6. Have a look for the other horizontal ones. This one's would be y equals minus 2. This one, we've got minus 2, minus 4, y is equal to minus 5. Just really quickly on this, with respect to reflections, if we've got a horizontal line, I said it's y equals to something, just recall that if it's y equal to 0, means it crossing through at 0 down here, it's the same as the x-axis. Can cause problems when we're doing reflection questions. Okay, so next let's have a look then at vertical lines. And hold on. So vertical lines, it is x equals. So we have a look at the questions that we've got. So we've got this one here. So this one's got to be x. Where does it cross at 6? So we've got x equals 6. This one I've got x equals 2, got x equals minus 2, and then here I've got x equals minus 5. Just going to cross out the ones we've used. So we've got these ones are all gone. Again, vertical line is x equals something. However, if it's x is equal to 0, so x equals 0 means it'll be crossing through here. It's the same as the y-axis. Okay, so next ones, let's look what we've got left. This one here you should recognise straight away. If you notice, this coordinate point here is 5, 5, 10, 10, 15, 15, 20, 20. So we know that this graph here would be y is equal to x. Again, let's get rid of that one. Have a look at the other ones we've got left, so there's bottom 4 here. This one, if you notice, well, the coordinate is minus 1, 1, minus 2, 2. So this one, again, most of you will recognise easily. It's y equals minus x. And then we have got a couple left. So we've got y equals 3x, y equals minus 2x, y equals 2x. Well, the only one that's different is this one here, y equals minus 2x, which we know means has a negative gradient, so the gradient is going down. So this one here has to be y equals minus 2x. And then the last two, y equals 3x, y equals 2x. Well, let's have a look what happens. As we go 1 across, we go up 2 up. As we go 1 across, we go 3 up. So therefore this one has to be y equals 2x, and this one has to be y equals 3x. So just a quick recap on recognising graphs before we go on to y equals mx plus c. So we have done this before, we have studied this, if we just remember what it means. So if we put y is equal to mx plus c, the m represents the gradient. Remember, the gradient is the steepness of your line, and the c is the y-intercept. So that means where does it cross the y-axis. So if I had an equation, let's have a think, y is equal to 4x, add 3 the gradient in this case would be equal to 4, and the y-intercept would be equal to 3. If I had a different example, let's say for example y is equal to 5 minus 2x, remember the gradient is always what's linked to the x, and be careful you check what sign it is. So in this case, the gradient would be equal to negative 2, and the y-intercept would be equal to 5. Okay, if you want to have a go at the questions below, so pause the videos and then I'll put the answers on in one moment. Okay, so the answers for the next are on the next slide, so just double check what you've got correct. So I've been lazy and I've just written m for the gradient and c for the y-intercept, so I didn't have to write it all out. And then hopefully you've got the same answers that I have got. So I'll just give you a moment to mark them. So next we're going to look at whether a point lies on a particular line. So here I've got a couple of examples, and then again I'm going to give you a little bit of time to go through these. So does the point 1, 4 lie on the line y equals 4x minus 1? I've got to recall that the first number is the x and the second number is the y, and all it is a substitution exercise. So I know if I substitute x equals 1 into here and I get an answer of 4, then I know it lies on the line. If it doesn't, then it does not lie on the line. So y is equal to 4. So if I've got y is equal to 4x minus 1, I've got 4 is equal to 4 times 1, because the value of x is 1, take away 1. So that's telling me that 4 is equal, well 4 times 1 is 4, take away 1 is 3. Okay, that is not true, so therefore it is not on the line. Let's have a look at the next one. So this is my x coordinate, this is my y coordinate. I'm going to see if it lies on the line, so I'm doing the same thing. So I've got 6 is equal to 4 times whatever that value of x is, which is 2, and then I'm going to subtract 2. So now that 6 is equal to 8, take away 2. 6 is equal to 6. That is true, so therefore it is on the line. Okay, so if you want to pause the video and then have a go at determining whether each of these points lies on these following lines. And your answers are as following. So if there's anything you're unsure about, just send me an email or just ask. Okay, so I'm going to look at finding the equation of a line. So as soon as I'm asked to work out the equation of a line, I'm just going to make myself a note that I want y is equal to mx plus c. The easiest thing to find every time is for c. Remember, this is the intercept. Where does it cross the y-axis? So I'm just going to circle where it crosses the y-axis. So I know straight away I can write down y equals mx plus 5. Even if I don't do anything else, that's going to get me a mark. I then need to work out the gradient. Now to work out the gradient, this is where we create a triangle. We have to choose a coordinate point. We can't choose halfway across a square. So I'm going to create a triangle, and then from that we're going to work out what the gradient is. So I'm going to choose this point here, and I'm going to choose this point here. So this point here, if you notice, crosses on the line, and this point crosses on the line. And then I'm going to count basically the squares. So we've got 1, 2, 3, 4, and it goes across by 2. Be really careful in an exam what the scale is, because if the scale is different, then we're going to make a mistake. If you remember, the gradient is always equal to what we call the y distance divided by the x distance. So it's y divided by x, which is 4 divided by 2, which is equal to 2. Now I haven't taken into account here whether it's a positive or negative gradient, but I can see from looking at the graph that this is a positive gradient because it's going upwards, and therefore I can just finish off by writing, well, y is equal to, the m in our case is 2, so y equals 2x plus 5, and that will get me 4 marks. So if you would just want to pause the video and have a go at the next one, remember your starting point every time is to write down y equals mx plus c. First thing, work out what you see is where it crosses, draw your triangle and see how you do. Warning, be careful of the scale. So pause the video and then in a moment I'll talk through. Okay, so the first thing I'm going to do is find where it crosses, which is at -6. So I'm going to write down y is equal to mx, in this case -6, because that's where it crosses the y-axis. Then I need to create my triangle. So I need to make sure I've got it where it crosses. So I can use this point here and I can use this point here. So it's just going to be a smaller triangle. It doesn't matter where you create the triangle, you will always get the same answer for the gradient. So, okay, so this distance here, now again, like I said, be careful of the scale, goes from -2 to -8, so that distance is 2. This distance, whilst it looks like it's far greater, is also 2 because of this scale. I know the gradient equals y divided by x, which is 2 divided by 2, which is equal to 1. However, I'm just going to check the gradient this time is a negative gradient, so that makes my gradient -1. So my gradient -1. Put it all back together. So I have the equation y is equal to -x, or I can write -1x minus 6, and that would be the equation of this line here. The final thing I want to look at is equations of parallel lines, and you might get this in an exam question. So I'm just going to remove some of the writing on here. Just see if I can also remove these lines. So you might be given a question where you've calculated or you've worked out what the equation of a line is, and then you're asked to write down an equation of a parallel line. Now if we think about what a parallel line means, it means that they are always the same distance apart. So I'm just going to create a parallel line the best I possibly can. So parallel line means this distance always the same distance apart. Now it doesn't matter if my parallel line was sat here, or actually if I picked it up and I moved it and it was up here. What I need to make a note of is that actually if it's a parallel line, it means its gradient is the same because it's the same steepness. So if I'm asked to write down an equation of a line which is parallel to y equals 2x plus 5, the first thing I'm going to write down is y is equal to 2x, because I know it's got to have the same gradient, it's got to have the same steepness. Now it doesn't matter if it's the same gradient and it crosses here, or it crosses at 1, or it crosses at 2, as long as it has the same gradient, it is parallel. So in this case, I've just got a line y equals 2x because it crosses at 0, or I could have y equals 2x at 4, or I could have y equals 2x minus 3. It really doesn't matter what the y-intercept is as long as your gradient is the same. Okay, final thing we're going to look at is being able to find the equation of a straight line that passes through 2 points when we haven't actually been given it as physically to look at. What I would suggest is that you always draw yourself a little sketch just to help you. So I'm just going to very quickly sketch x-axis and y-axis just to give me an idea of where the points lie. So if we recall, this is y, this is x. My first point is 1, 4, so let's say it's roughly here. My next point is 3, 8, so it's further across and higher up. And actually, if we were to join those 2 points together, like I said, it's just a sketch, we would notice that it's going to have a positive gradient. So that's just going to help me. So first thing I'm going to do is write down my equation. So y is equal to mx plus c. To calculate the gradient this time, it's slightly different. So I've got my x and my y, I've got my x and my y. I'm going to call this x1, y1. I'm going to call this x2, y2. First coordinate, second coordinate. So to calculate the gradient, what we did last time was we looked at the difference between the y's and the difference between the x's. So I'm going to do y2 and I'm going to take away y1, and that will tell me the physical difference between those 2 points, and then I'm going to do x2 and take away x1. Again, tells me the physical difference between these 2 points. So I've got 8, take away 4, and then I've got 3, take away 1. 8 take away 4 is 4, 3 take away 1 is 2, 4 divided by 2 gives me 2. So I know my gradient is 2. I know my gradient is positive because it's going in a positive direction. So I'm going to write y is equal to 2x plus c. So now what I need to do is work out what the y-intercept is. Well, I have pairs of coordinates that are linked together. So it doesn't matter whether I use the first pair or the second pair. I'm now going to substitute in x as 1 and y as 4. So I can say, well, 4 is equal to 2 times 1 plus c. So now 4 is equal to 2, add c. What does the value of c have to be to make it equal to 4? Well, 2 add 2 makes 4, so I know c is equal to 2. Therefore, my final equation is y is equal to 2x add 2. So just go through it one more time. I've done a rough sketch so I know whether I've got a positive or a negative gradient. I've labelled x1, y1, x2, y2. To calculate the gradient, I always start by y divided by x and looking at the physical difference between y2 and y1. So it's 8 take away 4, and then the same with the x's, 3 take away 1. 4 divided by 2 is 2, so my gradient is equal to 2. I then substitute in either this pair of coordinates or this pair of coordinates. It doesn't matter which pair you use, you'll get the same answer. So I've chosen this one here. I've let the value of x take 1 and the value of y take 4. So I wrote 4 is equal to 2 times the value of x, which was 1, add c. So 4 is equal to 2 add c. What do I need to add to 2 to make 4? Well, it is 2, so therefore my y-intercept is 2. My equation is y is equal to 2x add 2. One for you to have a go on your own. I'll give you a couple of minutes if you want to pause the video and then I'll go through it. The only reason I've done this one is because I've put a negative in it just to make it slightly more complicated. So I'm going to do the same thing that I did on the last one. I'm just going to draw myself a little sketch of what it roughly looks like. So this is my y, this is my x. I've got the point minus 2, 2, so approximately here, and then I've got the point 2, 18, which is here. So again, it's going to have a positive gradient. First thing I write down is y is equal to mx plus c. I'm going to calculate the gradient, if you remember, by doing y2 minus y1, x2 minus x1, and see what it comes out with. If you need to, label these. So we've got x1, y1, x2, y2. So I'm going to have 18 take away 2 over 2 minus minus 2. So this is where the negative comes in, be really careful. So I've got 16 divided by 4, which gives me a gradient of 4. So I've got y is equal to 4x add c. So now I need to work out the y-intercept. This is where you choose a pair of coordinates and you substitute in the values of x and y. Now it doesn't matter which pair you use, you get the same answer. I'm going to avoid this one because it's got a negative number in it and I don't want to make a mistake. So I'm going to stick with this one here. So my y value is 18. So 18 is equal to 4 times the x value is 2, add c. So 18 is equal to 8, add c. Well, what do I need to add to 8 to get to 18? I need to add 10. So c is equal to 10. So my final equation is y is equal to 4x, add 10. So on the next slide, I've got some for you to practice if you feel it's something that you need to do. So there's some questions at the top and your answers are on the bottom.